All right, here's your Chapter 1, Part 2 study guide. I gave you a table to start number 1. It shows the average high temperature for Hastings over the first 6 months of the year. So like January had an average of 29 degrees, February 35, March, April, May, June, so on and so forth. Pretty accurate, okay? Now, for number 1, I asked you to find the line of best fit. I know you don't have your calculator, but again, what you should have done is you should have come to Google Classroom right here. And I just showed you this link. Click it, and it brings you to this thingamajig. And then you are going to put all of your data in right here. I already put it in. So X values 1 through 6, Y values 29, 35, 40, 55, 68, whatever. Come down here, you leave this blank, and you hit this button. I accidentally hit this once. Not great. Click. Okay. Now look at y equals 9.82857x plus 15.9333333. So you should round to this number 2 decimal places, so 9.83, since after the 2 I have an 8, rounds this up to 3. And then this one would be 15.93, because the number after the 3 is a 3, which tells me to leave it alone. All right, so with that, coming back here, whoops. There we go. That means the equation of our line of best fit should be y equals 9.83x plus 15.93. There it is. Okay. Now for number 2, it says use that to predict the temperature on the last day of school. And I specifically gave you that that's 5.2. I mean, I think the last day of school is in May. It's usually end of May, something like that. So, just took a number, whatever, 5.2. So we're going to take this, y equals 9.83, and we're going to plug in 5.2 for x. Now be careful. You should know this is an x value because it's a month. If we go back up to the top, I even told you a month is an x value. Now you're going to calculate. If you punch this whole thing into a calculator, or if you do it by hand, that'd be really impressive. You should get 67.05 when you round it to the nearest hundredths. Just to show you, because why not, right? We've got 9.83 times 5.2 plus 15.93. And you can see how I have 67.046, and that 6 tells me to round that 4 up to a 5. And if you leave it like this, I'll give you most of the credit, but if you want it all, you need to write degrees Fahrenheit somewhere. All right, now number 3 is find the slope between these 2 points. So here's where you were supposed to say y2 minus y1 over x2 minus x1. That's the formula I was showing you. Come up and label your points x1, y1, x2, y2, and then you just plug stuff in. So y2 is 0, y1 is 2, x2 is negative 10, and x1 is 6. Then I subtract. 0 minus 2 is a negative 2, and negative 10 minus 6 is a negative 18. 2 negatives will make a positive, and if you leave it here, you get most of the credit. But if you want all of the credit, you need to reduce down to 1 over 9. That's my final answer, 1 over 9. And we keep going. We look at number 4. Write the equation of a line passing through that point, given that slope. Now, the quickest and easiest way, in my personal and correct opinion, is to write this in point slope form. So this is your x1, y1, and then that's your slope. So y opposite of y1 would be a positive 5, times slope x opposite of x1 would be a negative 2, and then you're done. Now, there are many other ways of doing this. You could get graph paper, plot this, follow your slope until you find your y-intercept, whatever. If you found this in slope-intercept form, it would look like that. Y equals 3x minus 11, just in case you found it that way. All right, number 5, write the equation of a line passing through these 2 points. Well, no matter how you write an equation of a line, you're going to need the slope. So again, you should have said x1, y1, x2, y2. Write your parentheses. y2, let's get a little closer here. I like it. y2 in this case is 7. y1 is 1. x2 is 5. And x1 is 2. So 7 minus 1 is 6. 5 minus 2 is 3. 6 over 3 divides out to 2. So there's my slope. My slope is 2. Now there's a lot of different answers I would have accepted here. If you wrote it in point slope form with this first point, it would be y opposite y1 equals slope times x opposite x1. This would be a correct answer. And that's with your first point. Or you could have used your second point, this 5 comma 7. Then it would have been y minus 7 equals slope times x minus 5. I would have accepted that as well. And that's your second point. But again, if you do something, you know, weird, whatever, and it looks like I wrote paint. Point. Second paint. If you wrote this in slope-intercept form for some reason, it should have come out to y equals 2x minus 3. Multiple different ways you could have gotten that. Again, however you're doing it, I would probably recommend using these. I bet some people wrote it this way and then solved for y and got this. But, okay, flip it over on the back. All right, so now I gave you this graph. And I asked you to find the line on this graph. Now, a couple different ways you could do this. You did need to find slope. Now, on this graph, it's kind of hard to just count slope because each one of these boxes is going up by 5. But if you did count slope correctly, you should have gotten 2 over 1. Now, I also gave you 2 points, so you could have calculated slope. Let's call this x1, y1, and x2, y2. So in this case, y2 is 18, and y1 is 12. x2 is 5, and x1 is 2. So I get 6 over 3, ironically the same as number 5, but whatever, okay? And I get slope of 2. So now I would have accepted a lot of different things here. If you used one of these points in this slope, for instance, like this first point, y minus 12 equals slope times x minus 2. This is a correct answer. That's using my first point. Okay. If I used my second point up here, my higher point, however you want to say it, I would have gotten y minus 18 equals 2 times x minus 5. That would have been acceptable as well. Some of you also may have just looked at this and just kind of estimated what this is. Now, technically, that's at 8. But if you estimated it and you said y equals slope x plus, and you said anything near 8, if you looked at that and said, oh, that's like 7 or like an 8.2, I'm cool with it. Probably anything in between 6 and 9, or maybe 7 and 9, I would have accepted. If you had said that's 6, I would tell you that's wrong. If you had said that's 7, that's getting close. So let's say anything in between 7 and 9. But that is actually an 8, which you could find out by calculating, just taking one of these equations and solving for y. So these were the 3 answers I would have accepted, and then I would have been generous on this right here if you were just guesstimating off the graph. And then the last one, I know this one's everyone's favorite. Super excited, right? All right. So I gave you one equation that only has x's and y's. Awesome. So if I want to solve, I need to find another equation that only has x's and y's, meaning I need to get rid of my z's. So I'm going to use these 2 bottom equations to get rid of my z's. Now you can take numbers and flip them if you want. For instance, like this is a 1z and that's a negative 3z. Remember, I'm going to ignore the negatives for a hot second. But I'm going to take this 1 and 3 and I'm going to flip it. So 1 on top, 3 on bottom. And then I need to ask myself, if I do that, if I multiply here, 1 times negative 3z and 3 times 1z, is that going to give me opposites? Meaning, are my signs going to be different? And you should say to yourself, yes. The top one will be a negative 3z, the bottom one will be a positive 3z, so we're good to go. So I need to multiply the entire bottom equation by 3 and the entire top equation by 1. Now remember, when you multiply by 1, that does 87 buckets of absolute nothing. So this top equation is actually just going to stay the same. Negative 2x minus 5y minus 3z equals negative 9. This bottom equation, on the other hand, I'm going to take this 3 and I'm going to multiply every single piece here by 3, and that's going to change it. So 3 times x is a positive 3x. 3 times a negative 4y is a negative 12y. 3 times this 1z gives me a positive 3z, and you can see that these are going to cancel. 3 times 21 is 63. Now again, my whole goal was for these two things to go away, and they do. These are opposites, so 3z and negative 3z cancel each other out. So then I'm left with my x's, my y's, and this nonsense. Negative 2x plus 3x is a 1x. Negative 5y minus 12y is a negative 17y. And then negative 9 and 63 gives me 54. All right, I did all of that work just to find a second equation that only has x's and y's. All right, so I'm going to take my top equation here, this negative x plus y equals negative 6. And then I'm going to take the equation I just found, positive x minus 17y equals 54. And I'm going to use those two like I normally would with a linear system with two variables. So I'm going to look for opposites. In this case, I already have opposites, a negative x and a positive x. So those are going to cancel out. And then I add 1y and negative 17y, which gives me a negative 16y. Then I add negative 6 and 54, which gives me 48. I can solve for y. I did all of that work just to get down to one variable. When I divide both sides by negative 16, I get the fact that y equals negative 3. Phew! And remember, that's only one of my 3 parts of my answer. Like if I want to come all the way down to the bottom here and, and write my answer, x, y, z, I just found out y equals negative 3. I still have 2 more pieces, but don't forget, that is by far the hardest. The first letter is by far the hardest. Okay, so from there, now, I'm going to use these equations and I'm just going to plug stuff in. I'm going to take this top equation, negative x plus y equals negative 6. Negative x plus y equals negative 6. I'm going to come and say, we just found out that y equals negative 3. Plug it in. All right, so adding a negative, that's the same thing as subtracting, and this gives us a 2-step equation that we can solve. So if I add 3 on both sides, I get negative x equals a negative 3. And then I divide by a negative 1, because don't forget, if there is no variable, you can put a 1. And these go away, and I'm left with x equals positive 3. So look how much faster that was to find our second part of the answer. I can write this here, second part of the answer. So now all I'm looking for is a z. But good news is I have 2 of these. So I can take any equation that's got a z, it looks like I've got 2 of them, and I'm going to plug it in. So I'm going to use the bottom equation here. That bottom equation says x minus 4y plus z equals 21. But I know x is 3. We just found that out. I know y is negative 3, because we found that out earlier. So once I plug those 2 numbers in, I'm looking at an equation that only has z's in it. I don't have any other variables, so now I can just solve for z. Negative 4 times a negative 3 gives me a positive 12. So now I have 3 plus 12 plus z equals 21. 3 and 12 I'm going to squish together to give me 15. Then my last step here is it looks like if I subtract 15 on both sides, I get the fact that z is equal to 6. Again, did not take that long. Once I had one variable, I think it took me longer to get y than it did to get x and z combined. That's it. Now, if you wanted to double check and make sure you were right, you could come back and punch all of those into our original equations. I'm going to do that just for fun. Check this nonsense out. Go a little closer than that. Okay, the first equation that says negative x plus y equals negative 6. Okay. So I'm going to start with negative x. Now we said x is equal to 3. So negative 3 plus y is equal to negative 3. So I just plugged in x and y. Negative x plus y, and that should equal to negative 6. I hit enter and it does. So go to my second equation, negative 2x minus 5y minus 3z equals negative 9, and I'm going to plug in all 3. So negative 2 times x, which is 3, minus 5 times y, which is negative 3, minus 3 times z, which is 6, and if I did this correctly and I hit enter, it all should come out to this negative 9 right here, which it does. Last equation, x minus 4y plus z equals 21. So x minus 4 times y. So x was 3, minus 4 times y is negative 3, plus z, which is 6. And if I hit enter, I should get 21, and I do. That's how I double check my answer. So now I know that this negative 3, 6 is correct. Boom, done. You know, I finished this whole video and then realized I had skipped a part where it says write a sentence describing slope here. Wow. So I wanted to come back and do that. Now my slope was 2 over 1. Don't forget that 2 is the y value and 1 is the x value, because we always do rise over run or y's over x's. So I put 2 inches, because my y value is inches, over 1 pound, because my x value is pounds. So if I were to write a sentence here, I would say something along the lines of, my spring will increase 2 inches in length. Let's make this stuff go away so it's less distracting. 2 inches in length for every 1 pound attached. Something like that. 2 inches in length for every 1 pound attached. This is basically saying it's going to get longer by 2 inches approximately for every pound that you attach. There you go.